Many consider the Grand Canyon to be one of the wonders of the world. Certainly nowhere else can one view as much of Earth's geological history in one place, with about a third of the history of our planet exposed. The Colorado River, which is relatively new, has eaten its way during a time period of maybe 3 to 5 million years through much older rock layers and then expose them in a way which we simply don't see in other parts of the world. In other parts of the world, these rock layers and others are certainly present, but they are typically deep under vegetation and not visible to the naked eye. We see a beautiful demonstration of the geological principle of superposition. In general, younger layers of rock lie over older layers of rock. If one were to look at the deepest part of the Grand Canyon near the Colorado River, one sees the oldest rocks, which were formed long ago in the Precambrian, about 1.8 billion years ago. There are rocks above them formed later in the Precambrian, known as the Grand Canyon supergroup, formed between 1.2 billion years ago and 700 million years ago. Then the majority of the Grand Canyon dates from the Phanerozoic eon and specifically the Paleozoic era, from 500 million years ago or so to 250 million years ago. Specifically, there are layers of the Grand Canyon which were laid down during the Cambrian period at the beginning of the Paleozoic era. There is a thin layer which was laid down during the Devonian period. There are layers which were laid down during the Carboniferous period, and there were layers which were laid down in the final period in the Paleozoic era, the Permian period. So all of these layers date to the Paleozoic era. Why don't these layers include the Mesozoic era and Cenozoic era? Well, these layers were once there, but they have eroded away. This area of the country has undergone great uplift, and erosion has removed these layers, but one can see them in nearby areas, such as these regions of the Painted Desert within the Petrified Forest National Park. Why are there time periods which are missing? Well, over this enormous time expanse, great changes have occurred in this part of the country. It has been the bottom of the ocean. It has been coastal waters. It has been dry land. The area has been part of a supercontinent, Pangaea. Pangaea has divided. There have been islands which have struck the western part of North America and fused onto it, causing uplift. There was a late Paleozoic ice age which lowered ocean levels. So all of these events affect whether sediments are being deposited or whether sediments are being eroded. And so therefore it isn't expected that one single area has a continual depositional environment forming sedimentary rocks throughout all of geologic time.